Hello students, welcome back to today's class on playing with numbers, and in that we are going to discuss HCF and LCM. In the previous classes we learned what is HCF and we also learned how to factorize a number, but we didn't discuss how to find HCF or LCM using some methods, so that we are going to discuss in today's lecture, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So, as in the last class, when we discussed about HCF, okay, which is the highest common factor, we learned a method called prime factorization, how to find the prime factors of a given number. Using that method, let us try to find HCF of 12, 16 and 28 using prime factorization. Okay, so for the number 12, let me write the tree, factor tree, and also I'll tell you the other method also. Okay, so for number 12, I can write 1 into 12, and the number 12 can be written as 2 into 6. We need to write all the factors such that we get a prime numbers at the end. And for this number 6, we go with 2 into 3. So for the number 12, we can write as 1 into 2 into 1 into 2 into 2 into 3. 1 into 2 into 2 into 3. You can go in this method, or you can simply divide this 12 with all the prime numbers. 2 6, 2 3 times, and 3 ones. So here also 1 into 3 into 2 into 2, you will get the same factors. This is called factor tree. We are trying to bring the factors, right? Okay, the next one we are going to discuss is 16. So 16, if we write the factor tree, we can write it as 1 into 16. That 16 can be written as 2 into 8. 8 can be written as 2 into 4. 4 can be written as 2 into 2. So we can write 16 as 1 into 2 into 2 into 2 into 2. So 1 into 2 into 2 into 2 into 2. Right? In the same way, we have the next number 28. 28, again, here also 16 you can directly divide with 2. 2 8 16, 2 4s are 8, 2 2s are 4, and 2 1s are 2. Right? So 2 into 2 into 2 into 2, you'll get the same answer. Now, let's move for 28. 28 can be written as 1 into 28, 2 into 14, 2 into 7, and that's all. We have all the prime factors here. Okay, so that will give you 1 into 2 into 2 into 7. So we got all the prime factors for this one as well as for this one, number 12, 16 and 28. Now the question is, we need to find all the common factors, and in that we need to discuss the highest common factor. Okay, so what are all the common factors? 2 is a common, 2 is common, as well as 2 is common. Anything more? 1 is also common, but that's okay. Again, 2 is common, 2 is common, 2 is common. Anything more? 3 is here, but 3 is not here, 3 is not here. 2 more? No. 7 is there, but no. These are the only possible common factors. So common factors, you can say they are 2 and 2. So the 2 into 2, the number 4 is the highest common factor of all these numbers. 4 into 3 is 12, 4 into 4 is 16, 4 into 7 is 28. So this is how you can try to find the prime, you can try to find the HCF using prime factorization. Okay, so this method of writing is called factor tree. Okay, or you can simply divide, and also you can try to bring all the factors. Okay, so the next one, find the HCF of 56 and 64 by continued division method. So the method of division which we just discussed, that is how you try to find, that is called continued division method. Okay, so let's try to write the division for 56, 2 times of 28 if I am not wrong, 2 times of 14, 2 times of 7, and 7 times of 1. Once again, 7 to is 14, 14 to is 28, 28 2 is 56. Okay, so using this long division method, this is called continued division, or you can say long division. I can write 56 as 1 into 7 into 2 into 2 into 2. And now 64 can also be written as 2 times of 32, 2 times of 16, 2 times of 8, 2 times of 4, 2 times of 2, and 2 times of 1. How many times? 1, 2, 3, 4, 5, 6. Okay, so 64 is 1 into 1, 2, 3, 4, 5, 6. So now tell me how many times this number is being repeated. I mean, which is common between them. Okay, so 2 is common, again 2 is common, and again 2 is common. So 2 into 2 into 2. Right? So 2 into 2 into 2. So that is how the HCF comes. 2 into 2 into 2. So the highest common factor will be the multiplication of all these two, which is 8. This is 8 into 7, and this is 8 into 8. So the highest common factor for both the numbers is 8. So that this is how you try to do with continued division method. Right? The previous one, the factorize, that's a tree method, factor tree method. Okay. So let's try to understand more about these methods. Find the HCF of 10, 35, 40 by prime factorization and continued division. So this one you can try to do that. Okay. Using the factor tree, try to bring all the prime factors and here continued division method and see whether you're getting the same answer in both the cases or not. Okay. So that is about HCF. You have more questions. Find the largest number which is a factor of each of the numbers. Largest number which is a factor, largest. Again, that says it is the greatest or the highest. Simply, we need to find highest common factor for all the three. Simple. If it is 2 numbers or 3 numbers, doesn't worry. Just follow the same method and try to write the HCF. Okay. So the next one we're going to discuss. Okay. Now, let's try to understand about multiples, because we need to understand what is LCM, least common multiple. The one we are going to discuss before is HCF and now it is LCM. Highest common factor, least common multiple. So let us try to understand what is a multiple. Okay. A number A is multiple of a number B if B is obtained by multiplying integers to A. Okay. It's very difficult to understand this one. Let us break that into several parts. A number A is a multiple of A. A number A is a multiple of number B. Is a multiple of B if B is obtained by multiplying integers to A. For example, okay, I have a number 24. I can write as 2 into 12. Correct? For the number 12, I am multiplying with 2 to get 24. Correct? So 24 is a multiple of 12. 24 is a multiple of 12. So let me write all the multiples of 12. Let me write all the multiples of multiples into. See, multiplying integers. We need to multiply integers. So 12 into 1 is 12. It is a multiple. 12 into 2, 24 is a multiple. 12 into 3, 36 is a multiple. 12 into 4, 48 is a multiple. So in that way, how many multiples you can write? Infinite multiples. You can write infinite multiples in this sequence. Okay. Every number is a multiple to itself. Every number is multiple to itself. Correct? And every number is multiple of 1. Every number, you can take 57, let us say. It is 1 into 57. So it is a multiple of 1. 1 into some number, 1 into 57 is 57. Correct? You can take any number, 1 into any number. Okay. So 1 into, let us say 10, you get 10. So 1 is a multiple of 10. Right? So now, let's try to understand what is least common multiple. What is least common multiple? When we are discussing about multiples, when we are going for common multiples, C stands for common. Whenever we have common, it is not just for one number, we are having multiple numbers. We are having multiple numbers. So, least number that is divisible by all the given numbers is called least common multiple. least number that is divisible by. This is very important. Okay, for example, I have a very small numbers 4 and 6, let's say. Okay, there is a number 12 which is divided by 4 as well as 6, which is divisible by. 12 is divisible by 4 and 6, correct? Even 24 is there, 48 is there, but out of all these, the least number is 12, which is the least common multiple. 4 into 6 is 12, 6 into 4 is 12. So 12 is a multiple of 4 and 6. 12 is a multiple of 4 and 6. Okay, LCM of 15 and 10. Least common multiple, 15 and 10 means least common multiple. So 15 and 10, I'll write 30, answer as 30. Just tell me whether it is correct or wrong. How? We'll see. There are some methods for that. But how to get that 30? 15 into 2 is 30, correct, and 10 into 3 is 30. Now, I know this is a common multiple. But my question is there any other number which is less than 30, which is a multiple of both the numbers 15 and 10? Is there any number which is less than 30, which is again a multiple of 15 and 10? No. This is the least possible number. This is the least possible number, and that is 30. That is the LCM, least common multiple. Okay. So methods to find LCM, we have division method as well as we have a prime factorization method. We have division method as well as we have prime factorization method. Okay. So now let's try to understand more about this one, LCM by prime factorization method. So let's try to bring all the prime factors. Okay. Find the LCM of 12 and 15 by prime factorization method. So 12 I'll write as 1 into 12. 12 I can write as 2 into 6. 6 I can write as 2 into 3. Right? So 12 we can write 1 into 2 into 2 into 3, and 15 can be written as 1 into 15 and 15 as 3 into 5, and that's it. No other numbers for that. Okay. So 15 is given as 1 into 3 into 5. These are the prime factors. Now the point is how to find the least common multiple. First of all, see which numbers are common for these two. Which factors are common? You can carefully see 3 and 3 are common. So write that number once. Whichever number is common, just write that once. Next, write all the remaining numbers. 2 into 2 into 5. 2 into 2 into 5. 3 2s are 6 into 5 2s are 10. 6 into 10 is 16. So, the least common multiple LCM of 12 and 15 is 16. 12 into 5 is 60 and 15 into 4 is 60. So, 60 is a multiple of 12 and 15. There are more multiples as well, but the least out of that is 12 and 15. Right. Let's move for the next one. Find the LCM of 48, 56 and 72 by prime factorization method. Again, the same method. I am not going to do that. I am leaving that for you. Just take all the prime factors, try to find all the prime factors and see which all common things are there. Just write once and write all the remaining as it is. Okay, so please try to do that. Now, let's try to find the LCM by long division method. How to go with long division method? Let's see here. Find the LCM of 84, 112, 196 by division method. So now, carefully understand, the method is same for any number of numbers. Okay, you have 3 numbers here. Then method is same even if you have 4 numbers, even if you have 5 numbers. So, 84, 112 and 196. Let us try to divide all the numbers with one common multiple, one common factor. Let's start with 2 and be sure that we are doing only with the prime numbers. Okay, so 270 or 242s are 2, 6, 2, 5, 10 and 1, 2, 56 are 112. 2, 9, 8. Okay, 98 are 196. 1 second we can go with 2. 2 ones, 2 21s, 2 28s, 2 49s. Now careful observe, we can directly divide with 7. Okay, as all the numbers are multiples of 7, 7 is itself a prime number. 7 threes, 7 fours and 7 sevens. It is again 7 into 7. Is there any other number? 4. 4 is still not a prime number. Okay, so we'll divide with 2 first of all. 3. Now see here, we cannot divide 3 with 2. So write the same number as it is, but don't try to divide and don't write 3 by 2, 1.5, nothing. Just leave it as it is. That means it is not a factor. So don't divide that. 2 2s, and this also you cannot divide 7 by 2. So it is the same. So I think we can leave it here because all the numbers are prime numbers. So now LCM will be the multiple of all these prime numbers. The product of all these prime numbers, 1, 2, 3, 4. 2 multiplied 4 times into 7 into 7 into we have 1 3 here. All these are prime numbers. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 into 3 48 into 7 7s 49. 16 into 3 is 48 into 49. So how to find this 48 into 49? Let's try to understand. 8 9s are 72, 9 4s are 36, 36 plus 7 43, 9 4s 36, 36 plus 7 is 43, 8 4s are 32, 4 4s 16, 17, 18, 19. Okay, so that becomes 2, 5, 13, 2. So that will give you 2, 3, 5, 2. That will give you 2, 3, 5, 2. Okay, so this is how you can go with the division method and you can find the LCM. You need to bring all the common factors only in prime numbers, not in any other numbers. Okay, so multiplication of all these will give you 2, 3, 5, 2. That will be the LCM of all these numbers. Correct? So let's move forward for the next one. Find the LCM of 102, 119 and 153 by division method. So you can try to do that. I am not going to do that. Just the same method what we have done. So please do that and you will understand the method. You will get the correct answer. Okay, so let's move for the next one. Find the LCM of the same question. Okay, so difference between LCM and HCF. We have discussed what is least common multiple as well as what is the highest common factor. Let's try to have the difference of these two. What is that? LCM is least common multiple. HCF is highest common factor. This is common multiple. This is common factor. Here it is least. Here it is highest. LCM is always greater than or equal to the bigger number. If we have two numbers, let's say 12 and 24. Okay, you try to find the LCM, you will get the answer as 24. It is always greater or equal to the bigger number. Here the bigger number is 24. It is always greater or bigger. Okay, it is always less than or equal to the smaller number. The same thing. 12 and 24, if you find highest common factor, okay, you will get it as 12. It is always less or equal to. Here it is equal. In all the other cases, it is less. For co-prime numbers, LCM is a product. Co-prime numbers, but that means there are no common factors between those two except one. Okay, so for co-prime numbers, LCM is a product. For co-prime numbers, HCF is 1. For co-prime numbers, HCF is 1. Okay. LCM of any integer a and 1 is a. Any number a and 1, LCM is always a, and HCF is always 1. HCF is always 1. Right? So let's try to move ahead to see the relation between HCF, LCM and both the numbers. When we're taking two numbers and we're finding HCF and LCM, let's try to understand what is the relation between these two. The relation here says that LCM into HCF is equal to the product of two numbers A and B. The product of two numbers is equal to the product of LCM and HCF. Product of any two numbers is equal to product of their LCM and HCF. Okay, let's try to take a few examples, verify the relation for 10 and 24. So let's try to understand what is the LCM of 10 and 24 using the division method. Okay, so 2 5s are 10 and 2 12s are 24. Again with 5, let us divide 5 1s and 5 12s, because 12 remain as it is because 5 cannot divide that. Okay, next one, 12 is here, so divide with 2, 2, 1 will remain as it is, 2 1, 2 6, right? And here it is again 2 1 and 2 3s are, and here it is again 3 1 and 1. All these are prime numbers. So 5 2s are 10, 10 2s are 20, 22s are 40, 43s are 120. Once again, LCM will be 2 into 5 into 2 into 2 into 3. So 5 2s are 10, 10 2s are 20, 22s are 40, 43s are 120. That is the LCM. Now let's try to understand the HCF of these two numbers. Okay, so 10, let me write all the prime numbers, prime factorization, 1 into 2 into 5. 1 into 2 into 5, and 24 can be written as 1 into 2 into 3. So there comes 6, and still we have 4 into 2 into 2. 3 to the 6, 6 to the 12, 12 to the 24. So now tell me which factors are common. 1 is common, 2 is common. That's it, right? So HCF is equal to 2. HCF is equal to 2. So now tell me, in these two methods, what is LCM into HCF? In both the cases, what is LCM into HCF? You will get 120 into 2, which is a 240, and the product of numbers A into B. The product of two numbers 10 and 24, even this is 240. So this is enough to say that the product of numbers is equal to product of HCF and LCM. Alright, so let's move ahead for the next one. That is, if LCM of two numbers is a 216 and the product is 7776, what will be its HCF? A very easy relation. LCM into HCF is equal to product of A and B. What is LCM? 216. What is HCF? We need to find HCF is equal to A into B product is given as 776. So HCF is equal to 7776 by 216. 7776 by 216, right? So now tell me how to cancel maybe 216 tens, 20s, 30. 30 will be near 30. Okay, let me try for 30. What is 30? 0, 0, 0, 6 is 18, 3 1s are 3, 3 2s are, sorry, yeah, 18, 3 1s 3, 4, this will be 4, okay, and 3 2s are 6, so that becomes 6480, but still we are far ahead. Let me try 216 into 40, that will be greater than that. 216 into 4, 6 4 is 21, 4 1s 4 5 6, 4 2s are 8, 8640, 2160, sorry, yeah, 216 into 40 is 8640. So it will be number between 30 and 40. Let me try to find what is 216 into 36. All these are not necessary. You need to cancel with 2, then 3, then 4, whatever it is. But I'm trying to bring the direct factor out of that. 6 6 are 36, 6 1 6, 7 8 9, 6 2 are 12. 6 3s are 18, 3 1s 3 4, and 3 2 6. So 6, 8 8 16 17, 4 5 6 7, and 7 exactly. So 216 into 36 times is 7776, 7776, right? So that is how you can try to find the numbers or HCF and LCM when one is missing. Okay, so right, so we have one more question that you can try. Product is given as 3276, HCF is 6, find LCM. Straightforward question. Okay, right. We have a couple of more questions. HCF is 6, LCM is 36, one number is 12, find the other. All these are different applications of the same concept, right? I hope you understood all these about numbers. We discussed what is HCF and what is LCM. In the coming classes, we are going to discuss more applications like this on all the topics, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone, so now we'll go into a few questions, a few practice questions on the chapter friction. So my name is Shashan Reddy, I'm a graduate from IIT Dhanbad. Let's go into the questions. The first question is here, a very simple, straightforward question. Friction is a dash force. The options, contact and non-contact force. What do you think? Very simple, friction is a dash force, contact or non-contact? And the answer is friction is a contact force. Friction is what? Friction is a contact force, because for friction to act between two objects, they should be touching each other. They should be touching each other. If they are not touching each other, there will be no friction. So contact is necessary. Contact is compulsory. That means, right, which type of force is friction? Contact force. So very simple, very quick answer. Friction is a contact force. Good? Okay. Next. Friction can be exerted by solids, liquids, gases, or all of the above. Again, very quick. Simple. The answer is what? Friction can be exerted by all of the above. The solids exert friction. Liquids exert friction, gases also exert friction. That means all of the above would be the best answer. Good? Okay. Next. What is the cause of friction between two solid surfaces? I'll give you 30 seconds of time. So please write it down. Then you can compare your answer with mine. What is the cause of friction between two solid surfaces? Yeah, everyone. Think. Write it down. Write it down in your notes. What is the cause of friction between two solid surfaces? So 5, 4, 3, 2, 1, and the time is up. And what is the answer? There are 3 votes. Interlocking of irregularities. That's it. That's it. The key words are what? Interlocking of irregularities. And the rest of it is explanation. Interlocking of irregularities leads to friction. Okay, that is possible, that is simple reason. And the rest you can say, you have to start your explanation, your answer with this point. You have to say that every surface, every and any surface on a microscopic scale will be rough, will have irregularities. So when two substances, when two solids or when two surfaces meet, the irregularities interlock, and this interlocking of irregularities will lead to friction. Simple. Okay, 2 points. One, you say that every object will be rough, will have irregularities on the microscopic scale. First point. Second point is, so when two objects are in contact, the irregularities interlock and it will lead to friction. Simple? Good. Next. Select the ascending order. You have to be careful about the ascending and descending order. So select the ascending order of the different types of friction. You have static, sliding and rolling. Or you just go through the options and just select the correct answer. Go through the options and select the correct answer, everyone. We have to select the ascending order. I have 3 types here: static, sliding and rolling. What is that going to be? Select the ascending order of the different types of friction. And the correct answer is going to be option C. Rolling is the least among all of them. And static is the maximum. So rolling, sliding and static. And what is ascending order? Ascending order will mean increasing order. It's like this. 1, 2, 3, 4 is what? An increasing order from lowest value to highest value. Ascending order, the value will increase. So here, obviously, rolling is the least. Just a minute. Rolling is the least friction and static is the highest or maximum friction. Minimum friction, rolling, maximum friction, static. Static. Right in between you have sliding. So that is the order. Simple? Good. Next. Why is sliding friction lesser than static friction? Another interesting question. Why is sliding friction lesser than static friction? What do you think is the answer? I'll again give you 30 seconds of time. So please solve it. You have 30 seconds of time, so please solve it, everyone. Write the answer. Write down the answer. So why is sliding friction lesser than static friction? The time is up. What is the reason? See, in sliding friction as well as static friction, the reason behind friction is interlocking of irregularities. But in sliding friction, the interlocking of irregularities will be less when compared to static friction. That's it. So the basic answer is this. If I write down the main point, the interlocking of irregularities between two surfaces will be lesser when the objects are moving. And when the objects are moving, the friction that acts is called as what? Whenever the objects are moving, the friction that will act is called as sliding friction. So in the case of sliding friction, the interlocking of irregularities is less. Yes or no? That means, or I can say hence, sliding friction is lesser than static friction. Simple 2 points. You'll get full marks. That's it. In sliding case, or when the objects are moving, interlocking of irregularities will be less. Hence, sliding friction is less than static friction. That's it. Good? Okay. Next. This is again interesting question. A girl pushes a box with 30 Newton force. So start imagining there is a box and a girl is pushing it with what force? 30 Newton force. But the box does not move. So it's a heavy box. So the girl is pushing it but the box is not moving. Which friction acts on it? Yeah, everyone? Which friction acts on it? What will the friction be? The box is not moving. The box is at rest. The friction acting will be static friction. So look for the option of static friction. Do we have static friction? Yes, we have static friction in A and C. We have two options. So wherever you have kinetic, that is wrong. So between A and C, then you have to select whichever is the correct answer based on the other information given. Or what we have to find out? We have to find out the magnitude of the friction acting. Now how will we do it? You'll understand this case. This is the box. The box is kept on a surface, right? And there is a girl who is trying to push it. And the girl is trying to push it with what force? With a force of 13 Newton. And is the box is moving? No. Box is at rest. So whenever any object is at rest, what does that imply about the net force? Whenever a box is at rest, what does that imply about the net force? That will mean net force is equal to 0. So there should be some force that is cancelling 13 Newton. Only then what will happen? Only then net force will become 0. And what is that force? That force will be exerted by the ground. Obviously, for net force to become 0, it should be opposite to this. 13 Newton is towards right. This friction, this force, which is friction, static friction, will be towards left, opposite direction. And for them to cancel out, the magnitude should be equal. That means this also will be 13 Newton. See, simple. If you just take an example, if this is 25 Newton, example, then 30 minus 25 is equal to 5. It will not be 0. We need it to be 0. When will it be 0? When it is 30 minus 30. So that is the reason why static friction is 30. So with the knowledge that we have, we can get the value of static friction in this case. And we got it. So the friction acting is static friction and the force is 30 Newton, and hence the correct option is A. If I look at C, it is static friction, okay, but it is given as 15 Newton, which is wrong. Option A is correct. Good? Simple. Let's continue. Name, look at this, again it's subjective question. Name any 3 activities in daily life that would not be possible without friction. That would not be possible without friction. Any 3. Yeah, everyone, any 3. Just write them down in your notes. There will be many. And we need only 3 of those many. Right? So, you tell me, just write down any 3. Any 3. Name any 3 activities in daily life that would not be possible without friction. So if I write down a few of them. One is we will not be able to write. We will not be able to hold things. We will not be able to lift things. We will not be able to walk. We will not be able to run. We will not be able to move. Anything. I have written 4, but you can take almost all the things. And all those things will not be possible without what? Without friction. You cannot write. You cannot hold objects. You cannot lift objects. You cannot walk, or you cannot run on. There is many things that you cannot do without friction. Good? Wonderful. Next. Does drag depend on the speed of the object? What do you think? Does drag depend on speed of the object? Yes or no? But the first task for you is to understand what is drag. And then you can answer it yes or no. But you tell me, I will not give you a clue. Does drag depend on speed of the object? Yes or no? Yeah, everyone? And the answer is yes. So first of all, what is drag? Drag is nothing but fluid friction. So when I say fluid friction, you can imagine it as friction by water, or you can imagine it as friction by air. And for this particular question, it is easier to understand it in terms of air. Friction by air. Let's say you're cycling. You're cycling. In first case, you're cycling at a lower speed. In the second case, you're cycling fast. First case, you're cycling slow. Second case, you're cycling fast. And in which case will the friction be greater? It will be greater in the case where You are cycling fast. Yes or no? You can feel the air pushing you back. In which case does the air push you back with a greater force? When you are cycling fast, right? So that means drag depends on speed of the object. The answer is yes. Greater the speed of the object, greater the drag. You can even write it down. Greater the speed of object. Greater the speed of object, greater the drag. Is that clear? Yes? Good. Next. Friction is a necessary evil. It's a very important statement. Friction is a necessary evil. Explain the statement. So I'll give you 30 seconds of time. 30 seconds should be enough. So please write it down. In very simple points, very short points, please write it down. Write down the answer and you can compare your answer with mine. Five seconds more. 3, 2, 1, and the time is up. So here we have to explain it. It's very simple. You can justify both of them. Friction is necessary. Just give an example. For example, I'll say that for holding objects, without friction you cannot hold objects, so friction is necessary for holding objects. Then friction is evil. Another example. Where is friction evil? It causes damage to machines. It damages the machines or shoes, or you can say any example. It damages machines by what? Or through wear and tear. Right, wear and tear. So that's one example. So hence see, friction is necessary in these cases and friction is evil in these cases. So you combine both of them and you say friction is a necessary evil. Now you might say, sir, I have taken another example for these two cases. It's fine. You can take any example, but just take proper examples for friction is necessary and friction is evil, and finally you can write down a statement. Hence we can tell that in some cases friction is necessary and in some cases friction is not necessary. That is the reason why friction is a necessary evil. Good? Okay. Next question. Imagine that an object is falling through a long straight glass tube. So imagine a long straight glass tube, long one, held vertical. It is vertical, like upwards, not like this, not like this. It is this vertical. Air has been removed completely from the tube. Air has been removed completely from the tube. That's a very difficult task, by the way. Will the object experience any force of friction while it falls down? Yes or no? And I'll give you another condition here. Friction is not touching the walls of the glass tube. The ball, right? Ball. Sorry, the object. The object is not touching the glass tube. It is, right? The object is not touching the glass tube and air has been completely removed. In that case, will it experience any force of friction? What do you think is the answer, everyone? What will the answer be? And the answer is no. Now, why is it no? It's a very simple reason. For friction to act, the object should be in contact with any other object. Now, imagine this. You have a glass tube. In that glass tube there is no air and the ball is just falling down. If there is no air, the ball will not be in contact with anything else. The ball is not touching anything else. It is not touching air, it is not touching the glass tube, it is not touching anything. So if the friction is not touching anything, who will apply friction? If the object is not touching anything, who will apply friction? No one will. That means in this case there will be no friction. And remember, friction is a contact force. Good? Okay, next question. A very simple one again. Planes are dashed to reduce drag. Just fill in the blank. I haven't given options because if you look at the options you can easily tell that. But your subjective questions are also important. So please tell me with what should I fill in the blank so that I can get the answer. What do you think? Planes are dashed to reduce drag. There is a special name for the shape. Planes are streamlined. They are made sharp at the beginning, sharp at the front to reduce what? To reduce drag. Streamlined. Okay. Now another question. Does friction produce heat? Yes or no? Very simple again. Does friction produce heat? What do you think? Yes or no? And the answer is yes. Give an example. One of the best examples is this. Rubbing your hands. When you rub your hands, your palms become warm. Yes or no? Why? Because when I rub my hands, friction will act between them and that friction produces heat. A very simple example. So friction produces heat, yes, and we have discussed an example. Okay. Okay, so that's it everyone. So we have practiced a good number of questions from friction. Right. So keep practicing. Thank you. Thanks a lot.
Hello students, welcome back to chemistry at Gravity Cloud. Let's continue our journey of chapter of metals and non-metals. Now in the last class we had gone through the physical properties of metals, right? Today we continue this chapter with the chemical properties of metal. So first of all, the first very property of metals when it respect to the chemical reactions is the reaction, or we can say electropositive nature. Now when I say electropositive nature, that means what? When I say electropositive nature, that means that metals, they have the tendency to lose electrons. Remember, whenever I say electropositive, electropositive means metals have the tendency to lose electrons. So when the electrons are lost by metals, what happens? They form the cations, right? They form the cations. Let's take the example. For example, we have sodium. For example, I have sodium, right? Now in the case of sodium, if I talk about sodium contains 11 electrons, 11 protons and 11 neutrons, right? Sodium metal, they have 11 electrons, 11 protons and 11 neutrons. Now we know that suppose one electron has 1 unit negative charge, right? One electron has 1 unit negative charge, and similarly one proton has 1 unit positive charge. This we know, right? One electron has 1 unit negative charge and one proton has 1 unit positive charge. In the case of sodium, when it is an atom, in the sodium atom you will see that there are 11 electrons. So total negative charge is 11 into minus 1, plus there are 11 protons, right? And one proton has plus 1 unit charge. So total positive charge is 11 into plus 1, right? And when it comes to neutrons has 0 charge. Neutron has no charge. That means it is equal to plus 11 into 0. Now when you will calculate it, it will be minus 11 plus 11 plus 0, which is equal to 0, right? That means sodium atom has no charge. Now suppose this sodium atom, it loses one electron. This sodium atom, it loses one electron. So what will happen? It will form the Na plus ion along with the electron. When this atom, it loses one electron, we know what is the electronic configuration of sodium. It contains 11 electrons and we write it as 281. Right? If we draw the sodium atom, if I draw the sodium atom electronic configuration in the form of shells, it will be like this. This is my nucleus, right? This is my first shell, second shell and third shell, right? Now we know the innermost shell contains 2 electrons. Second shell contains 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last shell contains 1 electron, like this. Right? I told you that sodium atom, it forms Na plus. How? By losing 1 electron. So the last electron, it will be lost by sodium. When this electron goes out of sodium, what happens? When this electron goes out of sodium, what will happen? It will form Na plus. Now in Na plus, how many electrons are there? 10 electrons. Right? In Na plus, we have 10 electrons because last electron is lost. And how many protons are there? Protons will remain same and neutrons will remain same. Remember, in Na plus, because we know protons and neutrons, they are inside the nucleus. Inside the nucleus, we have protons and neutrons. But for the formation of Na plus, only electron is removed. Not proton, not neutron. Right? That means Na plus has 10 electrons, 11 protons and 11 neutrons. So what is the total charge? Total charge will be equal to 10 into minus 1 plus 11 into plus 1, right? Plus 11 into 0, which is equal to what? Which is equal to 11 minus 10, which is equal to 1. That means sodium atom, when it loses 1 electron, it will have plus 1 charge, right? It has this plus 1 charge. That is why the metals, they are electropositive in nature, means they have tendency to lose the electrons. That is why sodium atom, it loses 1 electron to form Na plus, right? So the metals, when they form the ions, which are positive, are called cations. Simple. Basically cation means positive ions. Cation mean positive ions. Simple. Right? If I take another example, let's suppose we take the example of magnesium. So in the case of magnesium, what happens? We know magnesium has 12 atomic number. Atomic number of magnesium is 12. That means it contains 12 electrons, 12 protons and 12 neutrons. Simple. Now in this case, what will happen? Now initially the total charge of magnesium is what? The total charge of one magnesium atom. Let's say we have one magnesium atom Mg. So what is the total charge? It will be equal to 12 into minus 1 plus 12 into plus 1 plus 12 into 0. Minus 1 for the electron, plus 1 for the proton and 0 for the neutron. This is equal to minus 12 plus 12 plus 0 equal to 0. That means the atom of magnesium is neutral. Right? Now what will happen? Suppose this magnesium atom, it has 12 electrons and its electronic configuration is 282. Its electronic configuration is 282. Right? So if I draw the atom of magnesium, it will look like this. This is my nucleus. Around the nucleus, first shell, second shell and third shell. Right? Now we know first shell has 2 electrons. That means first shell has 2 electrons. Second shell has 8 electrons. That means I can have 8 electrons. 6, 7, 8. And the last shell has 2 electrons. Last shell has 2 electrons. Right? Now suppose I remove these electrons. I remove these electrons from the magnesium atom. This is my magnesium atom. I remove these 2 electrons from the magnesium atom. Right? And I told you that in the nucleus of magnesium atom, what do we have? Inside the nucleus we have 12 protons and 12 neutrons. Right? After removing these 2 electrons, after removing these 2 outer electrons, what do we get? We get the another shape of atom, and it will be like this. It will be like this. This is my nucleus, right? This is my K shell, first shell. This is my second shell. Now inner shell has 2 electrons and second shell has 8 electrons. Right? Since we have removed these 2 electrons, since we have removed the last 2 electrons, only 2 shells are left. This one and this one. Because this shell is gone. After we remove 2 electrons, this shell is gone. Now this species, it has 12 protons, because protons are inside the nucleus and we did not touch the protons. It has 12 neutrons, right? Because we did not touch the neutrons also. But it has now 10 electrons. Now it has 10 electrons, right? That means what is the total charge? What is the total charge? Total charge will be equal to 12 into plus 1 plus 12 into 0 plus 10 into minus 1. Right? This 12 into plus 1 for proton, 12 into 0 for neutron, 10 into minus 1 for electron. This will be equal to 12, right, plus 0 minus 10, which is equal to plus 2. That means from magnesium atom, when you remove 2 electrons, what happens? The charge comes to be plus 2. Net charge is plus 2, right? So that means this species is Mg2 positive. This species is Mg2 positive, right? That's why I told you that metals are electropositive. They have the tendency to lose the electrons, right? And from where they lose the electrons? From the outer shell. Always remember that metals have tendency to lose electrons. Metals have tendency to lose electrons from outer shell, right? Metals have tendency to lose electron from outer shell. Simple. Understood? That is all about the first point, that metals are electropositive in nature, right? Second chemical property is the reaction with oxygen. Now all the metals, they react with oxygen to form the metal oxides, right? Now when I say metal oxides, that means, let's see what is the meaning of metal oxides. Now just like I told you, metals, they react with oxygen to form the metal oxides. Simple. So if you consider many reactions, if you consider few examples as a reaction, first case will be calcium. Now calcium, it reacts with oxygen and it forms calcium oxide. Simple. Second case is the potassium. When potassium reacts with oxygen, it will form potassium oxide, right? This is my calcium oxide. This is potassium oxide. Next, suppose we have aluminium. Now aluminium reacts with oxygen to form aluminium oxide. So in short, all the metals when they are heated in the presence of oxygen, they will form the metal oxides, right? You can write here heat. You can here write as heat. Simple, right? When you heat, it will form metal oxides. Some metals, they don't require the heat, like sodium and potassium. Sodium and potassium are so reactive that you don't have to heat these metals. Just place sodium and potassium in the air, they will catch fire, right? So remember this thing. Just write it down, that sodium and potassium simply catches fire Sodium and potassium simply catches fire in presence of oxygen. So we don't have to heat sodium and potassium. They will simply catch the fire in the presence of oxygen. Right? Similarly, if I talk about zinc, zinc also reacts with oxygen to form zinc oxide. Right? Now important thing is that these metal oxides, they can be further classified into two categories. These metal oxides, they can be classified into two categories. First category is the basic oxides and second category is the amphoteric oxides. Right? That means what? That means that these two metals, calcium and potassium, suppose, for example, when they react with oxygen, they will form calcium oxide and potassium oxide. These oxides are basic in nature. Simple. And when it comes to the aluminium oxide, that is Al2O3 and zinc oxide, ZnO, these two oxides are, I will say, amphoteric in nature. Simple. Note it down that first two oxides, they are basic in nature and the last two oxides, they are amphoteric in nature. In short, the metal oxides can be of two types. There can be two categories of metal oxides. First category is the basic nature, second category is the amphoteric nature. Right? Now when I say basic nature and when I say amphoteric nature, what does that mean? There should be some meaning of it. Right? So let's see when I say basic nature. Right? In that case, I will tell you what happens. When I say amphoteric nature, in that case, what does that mean? I will tell you. Right? Let's consider another reaction of metal with the oxygen. Suppose we have copper. Suppose I have copper. Right? I heat copper, or I can say I reacted the copper in the presence of moist oxygen. Right? This is called moist oxygen. Now when I say moist oxygen, that means oxygen which contains moisture. Simple. Whenever we have the oxygen which contains moisture, it called moist oxygen. So when copper reacts with moist oxygen, it forms two compounds, copper hydroxide and copper carbonate. Right? This is what? This is copper hydroxide. This is copper hydroxide and this is copper carbonate. Simple. Right? This is my copper hydroxide and this is my copper carbonate. Now the point is, why I am telling you this reaction. This is important to understand. That why I am specifically telling you this reaction to understand. What happens, suppose you have the copper vessels. Right? Basically what used to happen, that in the previous times, right, some 100-200 years back, we used to use the copper vessels. Or we can say today also we use the copper vessels. And what happens, when you place the copper vessels in the atmosphere, or we can say in the open air, what happens? The oxygen which is present in the air along with the moisture which is also present in the air, they reacts along with carbon dioxide with copper. Right? Upon reaction, they will form the two compounds, copper hydroxide and copper carbonate. Basically, this copper carbonate is the salt. Right? And copper hydroxide, it is the base. Understood? So these two compounds are formed when copper reacts with moist oxygen. So you will see that whenever you will have the copper vessel and you place it inside, you will see a green lining is formed. A green coating is formed on the surface of vessel. A green coating is formed on the surface of vessel. Right? What is that green coating? That green coating is actually the copper carbonate plus copper hydroxide. Simple. Remember, whenever you take the copper vessel, even you can do it at home. If you have copper coin, if you have the copper metal or the coin made up of copper or the vessel or utensil made up of copper, just place it untouched for 1 week. Keep it untouched for 1 week. You will see that slowly and slowly the green spots, green color spots will be appearing on the surface of vessel or metal. Those green spots are appearing because the copper metal or the copper vessel reacted with the oxygen present in air along with the moisture, and it formed copper hydroxide and copper carbonate layer over it, right? That is why we always prevent the use of copper vessels. Okay, mostly what happens, we prevent the use of copper vessel because these salts or these compounds, they are not good for us. They can be harmful, right? This green coating can be harmful for us. It can be harmful for us. How it can be harmful? Because you will use this vessel to eat the food, right? And the food which you will put into it, the food which we will put into this vessel, it will mix with the green coating, right? And this green coating is the chemicals, and these are the harmful chemicals for us. So it may lead to the food poisoning. It may lead to the food poisoning. Simple. That's why we do not eat the food which is placed mostly in the copper vessels. Simple. Understood? Next point. Next important thing is regarding the understanding of basic oxides and amphoteric oxides. Now I told you what are basic oxides. There are few metals, they react with oxygen, they form the oxides, and the oxides are classified into 2 categories. First category is the basic oxides, second category is the amphoteric oxides, right? So basic oxides are what? Basic oxides are those oxides that react with water to form a base. Simple, right? In short, what will happen? In short, what will happen? Suppose we have metal, right? We have a metal. This metal will react with oxygen and it will form a metal oxide. It will form a metal oxide, right? This metal oxide, it can be either basic, right? Or it can be amphoteric. Simple. This metal oxide can be either basic in nature or in amphoteric in nature. When it is basic in nature, you have to give me the answer in the next class. In the next class, you will have to give me the answer that how amphoteric oxide, aluminium oxide acts, right? So try to find the answer of this question. I'll meet you in the next class and we'll solve this question, right? We'll try to get the answer of this question in the next class. So I hope you understood everything which is taught today. That's all for today. Thank you.